Okay, we're going to look at several types of transformations, and we're going to start by looking at a translation. Now, before we do the translation, let's graph our pre-image, which I have in the matrix in blue. And the top row is X, bottom row is Y. We have negative 2, 2, 0, 5, 1, 2, 3, 4, 5, and 3, 1. Then we will connect our dots to draw our image. So that's our pre-image. That's what we're starting with. Okay, now remember, as I said, the X values are on top. Left and right moves along, or your X values. As it moves left and right, that changes your X. So when it says translate right to, that means we're going to add 2, and we add because right is positive, to every value that's on our top row. So negative 2 plus 2 would be 0. 0 plus 2 is 2. 3 plus 2 is 5. And then it says down, so down would go with our bottom row, and we're going to subtract 5. So negative 3, 5 minus 5 is 0, 1 minus 5 is negative 4. So now let's graph those. We have 0, negative 3, 2, 0, and 5, negative 4. So it's as if we took the image and just moved it. Right 2 and down 5. And then our last example, we are going left 1 and up 1. So left would mean we would subtract 1 from the top. So negative 2 minus 1 would be negative 3. 0 minus 1 is negative 1. 3 minus 1 is 2. Then the bottom row is going up 1, so we add 1. So 3, 6, and 2. So when we graph that, we have negative 3, 3, negative 1, 6, so 1, 2, 3, 4, 5, 6, and 2, 2. Oh, wait a minute. I did negative 1, 6. It's negative. There we go. Notice again, it's the same image. It's just moved up. Left and up. So that is how you do translations. Okay, to do a reflection, let's first plot our pre-image, or the blue matrix there. So we have negative 3, 4, 1, 2, 3, 1, 2, 3, 4. Erase this extra dot. And then we have negative 1, 2, and 2, 2, and 4, 4. So that is our original image. Now, to reflect it across the y-axis. If you look up here, here's how we do reflections across the y-axis. All of the x values become negative, or change the sign. So if they're already negative, we make them positive. So that would be 3, 1, negative 2, negative 4, and then we leave the y values as is. So we would have 3, 4, 1, 2, negative 2, 2, and negative 4, 4. So it's as if you could take it on the y-axis and kind of flip it around so that it reflects there. Now if it asks you to reflect across the x-axis, the signs of the y change, or your bottom row. We're going to go back to our originally matrix here. So the x's stay the same, and we change the signs of the y value. So -4, -2, -2, -4. So we'll plot those. You have -3, -4, -1, -2, 2, -2, and 4, -4. So that's what it looks like reflects across the y-axis. Now if you're going to do it across y equals x, we have that right here. Notice the x and the y values just trade places. So we take the bottom row and move it up to the top. We move the top row to the bottom. And just as a reminder, y equals x is right here. So this is the line that we're reflecting across. So we have 4, 3, or -3, 2, -1, and then 2, 2, and 4, 4. And then across y equals x is right here. We flip the y and the x, and we change the signs. So the bottom row moves up and changes signs. So -4, -2, -2, -4. The bottom row moves down and changes signs. So 3, 1, -2, -4. So now we're going across y equals -x, which is right here. That's the line we're reflecting across. So we have -4, 1, 2, 3, -2, 1, -2, -2, -4, -4. Remember, it's the original blue image that we're reflecting here. The next kind of translation is a rotation, and that's if you could just take a point and kind of move it around a circle. And we'll show you as we get into it. And we're going to, again, start with our pre-image, the matrix that's given to us in blue. Let's graph that. We have -3, 1, 2, 3, 4, 1, 2, 3, 4, 0, 2, and 1, 6. So we'll connect those points. So this is our starting point for all of our graphs. Let's first of all rotate it clockwise, 90 degrees. So that would be right there. Notice the X and the Y are switching places, and the sign of the Y changes. So the X moves to the bottom, and then the Y's move to the top, changing signs. So -4, -2, -6. So let's graph that. We have -4, 1, 2, 3, 4, -3, -2, 0, and -6, 1. So if you can imagine a circle right here, you can see how it moved 90 degrees on that circle. So that's a 90-degree rotation. Then for the 180-degree rotation, the X and the Y stay where they are, but all of the signs change. So -3 becomes 3, 0 stays 0, 1 becomes -1, 4 becomes -4, 2 becomes -6, -2, and 6 becomes -6. So we'll plot those. You have 3, -4, 0, -2, and -1, -6. So 1, 2, 3, 4, 5, 6. And then you can see how that point on there is 180 degrees from our original image. Then for 270, the X and the Y switch places and the X's change signs. So the Y moves to the top again, 4, 2, 6. The X moves to the bottom and changes signs. So 3, 0, -1. Make that 3 better. So we have 4, 1, 2, 3, 4, 3, 1, 2, 3, 2, 0, and 6, -1. And you can see it on our circle here. All right, there's 270 degrees. Now 360, if you will notice, nothing changes. That's because 360 is a full rotation, takes you right back to where you started. So it would be overlap right here. That would be a full 360-degree rotation. The last type of translation is a dilation. A dilation can take our image and make it larger or make it smaller. So again, let's graph our pre-image with the matrix that's given to us. So that would be 0, 1, 0, -4, 1, 2, 3, 4, 3, -4, and 3, 1. So for the scale of 2, we do scalar multiplication. So we're going to multiply all that by 2. So that gives us 0, 2, 0, -8, 6, -8, 6, and 2. So let's plot those. 0, 2, 0, -8, 6, -8, and then 6, 2. So you can see it has the same basic shape and same basic proportions, it's just stretched out larger. Then for the scale of 1/2, we do scalar multiplication again. 1/2 times 0, 1, 0, -4, 3, -4, 3, 1. Notice it's making our image, it's going to make our image smaller this time. 0 times a half is still 0. We have 1/2, 0, -2, 3/2, -2, 3/2, 1/2. So to graph it, you have 0, 1/2. 1/2 is little in between 0 and 1. And then 0, -2. 3/2 is 1 1/2, so it would be between 1 and 2, and then up a half again. And then 3/2 and down 2. I did those backwards. Then we connect those. Now notice that number, a half, is smaller than 1, so it took the same image and it reduced it or made it smaller. So that is how you do a dilation.